I'm Anil Kumar, sharing with you some questions to interpret derivatives. I'll take up two graphs to explain how do we understand second and first derivatives. The question here is, sketch the graph of a function that satisfies following set of conditions. Second derivative of the function is -2. First derivative at 3 is 0 and value the function f of 3 equals to 9. That is the information given to you. You need to sketch the graph of this function, right? You can always pause the video, answer the question, and then look into my suggestions. Now, what all information do you get from what is given to us? Let's see that first. We are given that the second derivative is -2. What does that mean? It means on the domain of the function is concave down. It is negative, right? Second derivative is less than 0. So it's concave down. So we have concave down. Okay. Now, if all along the domain we have some function which is concave down, what do we expect? We expect a parabola, right? So we expect a parabola which could be like this. Does it make sense to you? So that is how we should think when we are given some conditions. So try to form an image in your mind. The second is the derivative at 3 is 0. That really means that the turning point is at 3, right? So that means the horizontal tangent at x equals to 3. So think about this as a turning point, right? So we have a turning point at x equals to 3, and we are also given the value of this f of 3 is 9, right? So turning point at x equals to 3, let me write that first. And then we are given that the value of the function at 3 is 9, and that clearly means that this vertex is 3, 9, right? So that gives us the vertex is at 3, 9. So from all this, it is absolutely clear that we are talking about f of x, which is definitely a parabola with vertex at 3, 9, right? So this much of information you can always get from the information given to us, right? So we could sketch a parabola kind of like this, right? So I'm not really making any scale here. Okay, so let me just draw a parabola, right? Let me extend this line, the x-axis. Okay, so on this parabola, it is important to label that this point for us is 3, 9, right? 3, 9. So that is the axis of this parabola. What you also get from this is that the second derivative is -2. And that gives you an idea of the second difference. So when you say second derivative is -2, then we also find that probably the leading coefficient is 1, right? The leading coefficient is 1. So we are definitely dealing with a function where a is 1, correct? So we could have some value of vertically translated here and there, but it seems that the function could be, if you could write in exponential form, shifted. So probably, let's write, we are talking about f of x, which should be kind of like x minus 3 whole square plus 9. You get an idea. So that is the kind of function which we are looking for, right? I haven't really drawn the graph keeping that in mind, but this is kind of additional information, right? Let me write down here additional information which you can derive from the given conditions, right? From the given condition. And if you take that into consideration, then a better graph will be what? Well, that gives you an idea that the x-intercepts could be at 0, right? So because square root of 9, if you take it on this side, the value of this function is 0. In that case, I'm sorry, I should have written negative here, right? Negative because opens downwards. So when you do square root of 9, then you get plus minus 3. And when you add 3 to it, so it becomes 0. So basically, you will notice that the graph actually will go through the origin. So let me redraw this graph and say this is my graph. So this becomes more precise. Do you understand? So this becomes more precise, 0, and that point expected to be, because that's symmetry, 6. So that will be precisely the graph which you could draw from the given conditions, right? However, even if you would have drawn roughly like I did, that was not wrong, correct? So at times, from the given information, what I'm trying to say is you may get exact graph rather than the family of graph. That's the whole idea, okay? Now let's look into the next example. The next example before us is to sketch the graph of a function that satisfies following set of conditions, right? So both are kind of related. We are given a couple of functions here. First, related to the second derivative. It says that the second derivative is less than 0 when x is less than minus 2. That means it is concave in that portion. Concave what? Less than 0 means concave down, right? It is concave up. Second derivative is greater than 0 when we are talking about a portion which is where x is greater than or equal to minus 2, right? So whenever you see at second derivative, think about concave up and concave down. That will always help. So let me rewrite this here and we will see how do we interpret it. The whole idea for this particular video is to understand, interpret the information, right? Second derivative is less than 0. That really means it is concave down, right? Concave down. Is it okay? Concave down means like this. That is the curvature when x is less than minus 2. So minus 2, let's say this is minus 2 for us, right? So during this half, in this half, it is concave down. So let me make a rough sketch here. It's kind of like this in this half. Do you understand? Now the second condition given to us is that the second derivative is greater than 0 when x is greater than minus 2. When x is greater than minus 2. That means there is a change in concavity. This portion is like concave up. So that means we have a point of inflection at x equals to minus 2. Do you get an idea? So that is what is the information which you can derive from the first condition. Now let's look into the second condition, which says that the derivative of the function f dash 0 is equals to 0. At 0, we have 0. That means we have a turning point. We have a turning point at origin. Is that okay? That means this. And also, we have a 0 at, when we say f dash minus 7 equals to 0, we have another turning point at x equals to minus 4, right? So what we are also given is a turning point at x equals to minus 4, right? So let's think about this as minus 4. So we have minus 2 here, minus 4 there, right? Now, we know there is a point of inflection at minus 2. How do we sketch a graph? Now, no values are given here, so we can be very flexible. That's the whole idea. However, we know that the curvature of the graph should be kind of like this. Whatever it is, we have a turning point here, right? And like this. Do you see that? So it kind of curvature is kind of like this till -2. However, at x equals to -2, the concavity changes, right? The concavity changes, and we also know that another turning point is really at, let me redraw this, I'm sorry. We have a turning point at x equals to -4. Let me draw like this. Turning point at x equals to -4, right? The concavity changes, and then we have a turning point somewhere here where x equals to 0, right? I should return not at origin, at x equals to 0. This is the x value. Is it okay? The derivative is 0. That means somewhere on the y-axis, correct? Anywhere it could be. So the graph will be kind of like this, concave down here, and curvature changes here. Do you see that too? We're changing the curvature, correct? And then we are going up. So that is how the graph is. And we are flexible about turning on the y-axis since we are not given any particular value. Perfect. So that is how it should be. So this is kind of important to understand that at -2 we have a point of inflection, right? And the concavity changes at -2. Before -2, that is from -infinity to -2, is concave down. Thereafter it is concave up, right? So let's write down f of x and x on this side. Anyway, I hope you've understood from these two graphs how to analyze or interpret the first and the second derivative, and sketch the graph once we know something about these derivatives. I'm Anil Kumar, and I hope that really helps. Feel free to share your questions, subscribe to my videos, and if you like, that'll be great. Thank you, and all the best.